Okay, so where the last video ended was right here. We were finding the velocity of the third section of the trip. 50 divided by a fifth of an hour gave us 250 kilometers per hour, and it was going south. So this is the end to part B of number 24. And then part C says calculate the average velocity for the total trip. So average velocity for the total trip is displacement over time. And we found the displacement in part A. It was 158 kilometers. And the total time is 20 minutes plus 40 minutes, which is an hour, plus another 12 minutes, which is a fifth of an hour. So 1 1/5 of an hour, or 6/5 of an hour, or if you want 1.2 hours. Do the math with this, and you should get 156 divided by 6 over 5. 131 2/3. If I did that right. 131, and then that'd be 0.6 repeating. I'm just going to double check that because I don't trust myself. Divided by, it was 158. Divided by 1.2. 131.6 repeating, yeah, kilometers per hour. And the direction is always the same as the total displacement for the trip. So north 51.57 degrees west. That is part C. And it says in part C, note that it's not, the average velocity is not the same as the average speed. To do the average speed, you'd add up the 100, the 150, and the 50. So you'd get 300 kilometers divided by 6 over 5. So, and it would be 250 kilometers per hour, which would be a lot closer to what he was going, right? This looks small because he's doubled back on himself. So remember, velocity is never an accurate picture once you've changed direction, which this guy did. All right, 2 more. Number 25. A swimmer is standing on the south shore of a river that's 120 meters wide. So here's my river, and the dude is standing on the south shore, and he's going to swim this way. Okay? He wants to swim straight across, so he wants to end up over here at this spot. And it tells you that he can swim 1.9 meters per second in still water. He drops a stick in the water and finds that it floats with the current to a point 24 meters west in 30 seconds. So the stick info is going to tell us how quick the current is flowing, because it goes 24 meters in 30 seconds. So from this, we can find the velocity of the water. We can do VAV is equal to delta D over delta T. And so that's just going to be 24 meters over 30 seconds. And so we'll find that the water is actually flowing 0.8 meters per second, and it's said to the west. So if Buddy aims directly here, the river's going to carry him over here. And he doesn't want to end up over here. He wants to end up here. So what does Buddy need to do? He needs to aim this way to let the river carry him down to where he wants to be. So the river is going to be 0.8 meters per second. It says with respect to the water, he can go 1.9 meters per second. This is west. And so the first part of the question wants to know what direction should he head? What is this angle going to be? So if you look at our diagram, you'll see that you have the opposite and the hypotenuse this time. So you have to use sine theta. So opposite would be 0.8 meters per second, hypotenuse 1.9 meters per second. Divide these and then do inverse sine, and you should get an angle of 24.9 degrees. So theta is equal to 24.90 degrees. But then we need direction. Well, we're measuring it from the north. He's standing on the south side wanting to go north. 24.90 degrees. And which way must he head? The river's flowing west, so he has to go into it if he wants to end up straight across. He needs to go east. So this is the answer to A. B says, if he follows your advice, determine how long it will take him to reach the other side. Well, earlier in the question, I didn't write it down, but it told us that this is 120 meters. So we have a delta D. And now we're looking for delta T. And we could find it if we knew his speed directly across. Remember, the D and the V always have to be in the same direction. So we can't use the 1.9 because it's going off at an angle. But we can get this because it's a right angle triangle. So for part B, we could do Pythagorean theorem, and it'll be V squared plus 0.8 meters per second squared, because V is one of the sides, is equal to 1.9 meters per second squared. So V will be equal to the square root of that 1.9 meters per second squared minus the 0.8 meters per second squared. So 1.9 squared minus 0.8 squared, and then take the square root, and you should get something like 1.72337. I'm not going to round very much because we're going to use this because we want to find the time. So now the time will be VAV is equal to delta D over delta T. So delta T will be equal to delta D over VAV. So delta T is equal to the 120 meters divided by 1.72337, etc., that you have in your calculator. So you can use the answer button if you happen to be lucky enough to have one of those. So it's 120 divided by that time, divided by that speed, and you get 69.63 seconds for the time. Okay, so that's number 25. One left, number 27. Number 27 says, a lone canoeist paddles from her cabin heading directly east. So she's going east. 27. When there's no wind, the velocity of the canoe is 1.5 meters per second. However, a strong wind is blowing from the north, so it's actually blowing south, and it's blowing at the speed of the wind is 0.5 meters per second. And so the question wants to know the resultant velocity of the canoe. So it wants this side. So again, just back to regular Pythagorean theorem. This V, we'll make this one canoe so that you can tell them apart. So it's just going to be equal to 1.5 meters per second squared plus 0.5 meters per second squared, and then of course square root for Pythagorean theorem. And when you do this, you should get 1.58 meters per second. Of course, we need an angle. So you have the adjacent side, you have the opposite side, so you would use tan. Tan theta will be equal to 0.5 meters per second over 1.5 meters per second. And you should get a theta of 18.4, I believe. Let me just double check that. 1 over 3 inverse tan. 18.43 degrees. So then we go down here, we go square bracket. First we were going east, 18.43 degrees, turned and went south. Okay, so now in this question, it says use vectors to calculate it and then check your solution mathematically. So we did it mathematically, but you could also practice your drawing to scale and see how close you can get here. Okay, so those were all of the relative velocity questions that I'd asked you to try.